As always, I'm going to start by labeling each of the rows, row 1, row 2, row 3. I'm going to scan through my variables and see which one will be the likely one to cancel out the easiest. And I think it's going to be the z's. So I'm going to start by doing, let's say, row 1 plus the opposite of row 3. So row 1 and the opposite of row 3 will enable me to cancel out the z's. So this is my little notation that I like to use as a way of keeping my work organized. Okay, so now I just copy down row 1, which is 5x plus 3y plus 2z is equal to 2. And now I'm going to add to that the opposite of row 3. So row 3's opposite would be negative x minus 4y minus 2z is equal to negative 16. And I'm going to add these two rows together. Okay, so we end up getting 4x minus y. The z's cancel out, and that equals negative 14. Great. Now I'm going to pick another two rows to eliminate z, and I think I'm going to do row 1 plus twice row 2. And if I do row 1 and twice row 2, this is going to enable me to also eliminate the z. Okay, so row 1 I'm just going to copy over again. 5x plus 3y plus 2z is equal to 2. Now I'm going to double every element of row 2. So it's going to be 4x plus 2y minus 2z equals 10. And let's get that set up. I'm going to add those together. And now I'm going to have a net of 9x plus 5y. The z's are eliminated, and that equals 12. So I could take these two rows, these two results I should say, and stack them one on top of the other. So in one case I've got 4x minus y is equal to negative 14. And in the other case I've got 9x plus 5y is equal to 12. So this boils down to just a 2 by 2 system, which was the earlier portion of the chapter. I'm thinking about elimination, and I'm going to multiply the top by 5 in order for that to happen. Okay, so when I do that, the new top row is going to become 20x minus 5y is equal to negative 70. The bottom row I'm going to leave unchanged. 9x plus 5y is equal to 12. And now when I add, the y's are going to be eliminated. So the y's cancel, and I'm left with 29x is equal to negative 58. Dividing both sides by 29, I get x equals negative 2. One down, two more to go. So I'm going to back substitute into either of these. I think I'll just go right here, and this will enable me to solve for y. So 9 times negative 2 plus 5y is equal to 12. So we get negative 18 plus 5y is equal to 12. 5y is equal to 30, and y is equal to 6. 2 down, 1 to go. So now I'm going to take both of these answers and plug them into one of the originals. So pick the original, which is going to have the lowest coefficients and the smallest numbers to work with, or it doesn't really matter, anything you like. I'm just going to use the middle row, row 2. So 2 times x plus y minus z is equal to 5. Now for x we got negative 2, for y we got 6, and now I can solve for z pretty easily. Negative 4 plus 6 minus z is equal to 5, or 2 minus z is equal to 5, or z is equal to -3. So it's customary to write your answer as an ordered triple in alphabetical order. So we start with -2, and then we have y, which is 6, and then we have z, which is -3. And I'll just put a box around this to finalize our answer. In this example, we're going to solve another 3x3 system of equations, but there's going to be an interesting outcome. I'm going to start by scanning each of my rows and decide which variable I'd like to cancel out. And I think I'm going to start with, I'm going to cancel out the x's, and what I'm going to start with is row 2 left alone, but then I want to add to that -2 times row 1. And that's going to enable me to eliminate the x's. So row 2 is going to remain unchanged. 6x plus 4y plus 8z is equal to 11. Now I'm going to multiply every element in row 1 by -2, which gives me -6x plus 2y plus 4z is equal to -8. Adding the columns, the x's cancel out, and I end up getting 6y plus 12z is equal to 3. Now I notice that every one of these terms is divisible by 3, so I'm going to rewrite this as 2y plus 4z is equal to 1. I'd rather work with the smaller coefficient, so simplifying that I think is a good idea. Now, because I eliminated x, I want to continue to eliminate x, but I have to use 2 different rows. So what I think I'm going to do is row 3, and then I'm going to do plus -3 times row 1, and this will also get rid of x, I should say. So row 3 is 9x plus 6y plus 12z is equal to -3, and then I have to multiply -3 times every element in row 1, which would be -9x plus 3y plus 6z is equal to -12. Okay, let's make that negative a little bigger. The x's cancel out, and now I'm left with 9y plus 18z is equal to -15. Now it just so happens that every one of these terms is divisible by 3. So that gets me 3y plus 6z is equal to -5. So at this point I'm going to take these two results and stack them one on top of the other. So we have 2y plus 4z, well, so we have 2y plus 4z equals 1, and we have 3y plus 6z equals -5. And to do elimination here, I'm going to multiply the top by -3 and the bottom by 2. So now we have -6y minus 12z equals -3. And we have 6y plus 12z, and that equals -10. That's a terrible one. Okay. Now here's where the interesting outcome happens. At this point, the y's go away, the z's go away, and we're left with 0 equals -13. Well, this is not true, ever. So this tells us that there's actually no solution. In our last example, we're going to solve a 3x3 system of equations, and it's also going to have an unusual outcome. So I've labeled my 3 rows, row 1, row 2, and row 3. I'm going to scan and see which variable is going to be easiest to cancel, and I think I'm liking the x's. And I'm going to start with row 1, and I'm going to add to that the opposite of twice row 2. And in doing this, I'll be able to get rid of the x's. Okay, so row 1 is going to remain unchanged. 2x plus y minus 3z is equal to 5. And now I'm going to double everything in row 2 and also negate it. So that would be negative 2x minus 4y plus 8z equals negative 14. Okay, when I add down at this time, the x's are eliminated, and I get negative 3y plus 5z is equal to negative 9. Okay, let me pick another 2 rows to get rid of x, and I'm going to do, how about this? Row 3, I'm going to add to that negative 3 times row 1. And we're going to get rid of x again. So row 3 is going to remain unchanged. 6x plus 3y minus 9z equals 15. And now I'm going to multiply every element of row 1 by negative 3. So that's going to be negative 6x minus 3y plus 9z is equal to negative 15. So this is an interesting outcome. This cancels, this cancels, this cancels, and this cancels. So we end up with 0 equals 0. Whenever you get an answer like this where the two numbers are the same, that means from a graphic standpoint that these two planes are the same. Row 1 and row 3 are the same plane. Now, when we compared row 1 and row 2, those two planes were not the same. They intersected in a line. So we have the two planes that are exactly the same and another plane that passes through it. So they're going to intersect at a line. Now if I do this with color, you might be able to visualize it a little bit better. So here's a plane. There's our first plane. We'll call this row 3. Or how about just I'll call it row 1. Now we've got this second plane, which happens to be the same as the first plane. So row 1 and row 3 are the same. So it's sort of like a blue and green at the same time, and I'll call this row 3. And then I've got this other plane that hits the other one, but in a line. So maybe row 2 looks something like this. So this would be our row 2 plane. When they come together, they hit a line. So this is the line represented by this right here. Now, the solution set is where the points intersect. Well, it's going to be all the points on this line here. And this line goes on forever because these planes go on forever. So the answer is actually infinitely many solutions. Infinitely many solutions. So that's definitely a weird case. And I think maybe this illustration hopefully helps.